Ratio should be pretty familiar. A proportion is an equation that states that two ratios are equal. The first and last numbers in a proportion are known as the extremes. The middle two numbers in a proportion, those are known as the means. An example of a proportion is something like this right here. 2 to 5 equals 4 to 10. In this example, the 2 and the 10 are the extremes, and the 5 and the 4 are the means. We could also write it with an equal sign in the middle of two fractions, and the same is true. The first and last thing we wrote are the extremes, and the two middle numbers we wrote are the means. In a proportion, the product, which is the result of a multiplication problem, the product of the extremes equals the product of the means. The way it would present itself is as we have written right over here. A over B equals C over D. If that's true, then AD is equal to BC. A lot of people will refer to this as cross multiplication. I'm guilty of that too, but I am going to try to refrain from that because a lot of people think cross multiplication means multiplying across and not so much diagonally, and I don't want to confuse anybody. So it's important that we just really think of it as the product of the extremes being equivalent to the product of the means. We have a few different ways to write the exact same proportion. As long as A and C are either lined up vertically or horizontally, same as A and B, B and D, and C and D, the proportion that we have set up will still be true. The next vocabulary term we're going to define is similar figures. Similar figures have the same shape, but not necessarily the same size. The symbol for similar is this little squiggly line that we often see on top of the symbol for congruence, which is a little squiggle on top of an equal sign. So when you list this symbol between a combination of capital letters, that means that we're describing a polygon similar to another polygon. Similar polygons are when two polygons have congruent corresponding angles and proportional lengths of corresponding sides. Polygon ABCD is similar to polygon WXYZ. The order we write the capital letters in does matter. Angle A and angle W are congruent. Angle B is congruent to X. C is congruent to angle Y. Angle D is congruent to angle Z. The order the letters are written in give you a lot of information. Side lengths that are proportional are AB to WX, BC to XY, CD to YZ, and AD to WZ. By writing out all four of those proportions together, that is actually an extended proportion. The next definition we're looking at is scale factor. The ratio of corresponding linear measurements of two similar figures. Here I have two right triangles. These are actually both 3, 4, 5 triangles. They are similar. All of their angles are congruent, and their sides have a common proportion. If we're given that triangle ABC is similar to triangle XYZ, Then we can find the scale factor by just comparing corresponding side lengths. I chose to use AB and XY. AB over XY equals 9 over 6, which reduces to 3 over 2. That means 3 to 2, or 3 over 2, is the scale factor. In this next example, I have two trapezoids. I also give you that GEOT is similar to RYMT. Angles G and R are congruent, E and Y, O and M, and T is congruent to itself. GE and RY will be proportional, just as EO and YM, OT and MT, and then GT with RT. Make sure you remember what we just spoke about regarding the order of these capital letters. It's important to take notice of pairs of corresponding sides for which you have the numerical measurement of both side lengths. That allows you to set up your scale factor. You can use your scale factor to compare your figures and find missing side lengths. I decided to use GT, RT, EO, and YM. 9 over 6 equals 7.5 over W, or even 6 over 9 equals W over 7.5. As I mentioned earlier, there are several ways that we can write equivalent statements to a proportion, and I just happened to write it in a different order this time. As I solve, I use the product of the extremes is going to be equal to the product of the means. I decided to multiply both sides by 2 to get rid of the 7.5. There are a lot of different ways that I could have done this. I didn't even go and find the products. I broke the numbers down more and then divided because I want to use smaller numbers, think smarter, not harder, and just reduce things until the only thing left was W equals 5. For the second part of the question, I needed to find the value of x. This time, I used the proportion 9 is to 6, as 6 is to x. And we found that x would equal 4. We're going to look at the perimeters and areas of similar figures. If the scale factor of two similar figures is a to b, or a over b, or written with words a to b, then 1. The ratio of their perimeters is a to b, a over b, or with words a to b. So the scale factor is the same as the ratio of the perimeters of similar figures. Just to reinforce that, the scale factor of two similar figures is equivalent to the ratio of their perimeters. However, the ratio of their areas is a squared over b squared, so if you just remember that since area is two-dimensional versus perimeter, which is one-dimensional, we're going to take our scale factor, which is also the ratio of the perimeters, and we're just going to square that ratio. And you square a fraction, you square the numerator and denominator separately anyway. For example 2, let's reference example 1 again. What if I was looking for the ratio of the perimeters of figure GEOT and RYMT? The ratio of their perimeters would be equal to my scale factor. To find the scale factor, I decided to use GT and RT since I had both of those lengths and their corresponding sides. 9 to 6 equals 3 to 2, or 3 over 2. We could write it several different ways. Since my scale factor is 3 over 2, my ratio of the perimeter of GEOT to the perimeter of RYMT is also 3 to 2.
For questions like this, it is important to pay attention to the order that the question asks you to find the ratio. Are they asking you to go from the smaller figure to the bigger figure? Or are they asking you to go from the bigger figure to the smaller figure? For this second bullet point, we switch the order that we refer to the polygons, which means that my scale factor will need to be changed around. I'll need to use the reciprocal and then square my scale factor. The reciprocal of 3 over 2 is 2 over 3, and 2 over 3 squared is 4 over 9. Example 3, find an approximate area. The area of a pentagon with side length 10 inches, that should actually say a regular pentagon, with side length 10 inches is about 172 inches squared. What is the approximate area of a regular pentagon with side length 4 inches? Well, the side lengths are going to help me find my scale factor. So for the scale factor, I went from my smaller figure to the larger figure, which was 4 to 10, and that reduced to 2 to 5. Which also means that the ratio of their perimeters is also 2 to 5. The scale factor also tells me that the area of the smaller to the area of the larger, that proportion, is actually 2 squared over 5 squared, or 4 over 25. I'm going to set up a proportion and then use the means and extremes. 4 over 25 equals A over 172. After I set the extremes equal to the means, I decided I wanted to simplify as much as I could without a calculator, and I even changed the 25 into a 24 to make things a little bit more doable. It didn't ask for the exact answer, so I tried to be resourceful and find a way to get an approximate answer without using a calculator. For the last problem, we needed to find the scale factor after we were given the areas of two figures that are already stated as being similar. The areas of the two figures are 50 centimeters squared and 98 centimeters squared. Since we saw before that if you have a scale factor of a to b, that's also your proportion of your perimeters. And if I square either of those, I will get my proportion of my areas. So basically we're going to work backwards. 50 over 98 must be a squared over b squared. Reduce 50 over 98, we get 25 over 49. Take the square root of both sides, and we get 5 over 7 is equal to a over b, so that is both our scale factor and the proportion of the perimeters of the two figures. Hope you liked the video. Hope it helped you out.